This is a question sent to me through email by Subhankar Paira, and the question reads, sir, when a resistance AB is added through a conducting wire across a battery. So, let me draw also so that you understand. So, there is a resistance AB. This is how we make the figure of resistance, although resistance never looks like this. When a resistance AB is added through a conducting wire across a battery. So, we have a battery, or let me write the symbol battery, and then there is a conducting wire. So, this is a conducting wire, and then it is added here like this. The potential difference between one end of the battery, say positive. So, this point, potential difference between one end of the battery, say plus, and one end A of resistance here, this is 0. So, if this point is A and this point, let us say C, then V C minus V A is 0. We always say that if the current is I and then resistance is R and this is V, then V is equal to I times R, and this I times R is the potential difference here to here. So, the potential difference here is taken as 0, the potential difference here is taken as 0. So, his question is, but in spite of 0 potential difference, a current flows between the two, why? So, that is the question. So, in Ohm's law we have studied this, that if you have a potential difference, then the current will be there, and that current will be given by this I equal to V by R. Now, if I look at this circuit, Shubhankar is very right that we take this V C minus V A as 0 and still say that the same current I goes here and the same current I goes here. Now, the clue is that this connecting wire is supposed to be thick enough, and we neglect this resistance altogether in comparison to this resistance. Okay. The conducting wires are supposed to be resistance less, all the resistance is here, and the resistance of this wire we say it is very small and we neglect it. So, if you do that from this equation itself, you can see that if this R is 0, if this resistance is 0, and then if I is, let us say 2 amperes, here 2 amperes, suppose it is a 6 volt battery and then this is 3 ohms resistor and the current is 2 ampere. So, this I is 2 ampere and the potential difference is 0, perfect, no problem. 2 ampere multiplied by 0 will give you 0. So, V equal to IR, Ohm's law is perfectly followed here. So, your resistance is 0 here to here, potential difference is 0 to 0 here, and then there is a current of 2 ampere, perfectly alright. And if you change the resistance here or change the battery here, this 2 amperes becomes a 1 ampere or 0.5 ampere or 1.5 ampere, does not matter, even then this equation will be okay. So, it is perfectly logical and it is in accordance with the Ohm's law.